Hi and welcome. I'm trying to learn Selenology. Today, what's on the far side of the moon, and after I've done it, we're going to do short impingement training. And if you participate in the short impingement training, then it's better to honest. And this is part 2. Now first biotics here. Why do we always see the same side of the moon? A full moon always looks the same as it orbits Earth. The moon also turns very slowly on its axis. The spin and orbit move at the same time. So the same side of the moon will always face towards Earth. So while the moon is making one orbit around the Earth, it also makes one spinning on its own axis. It's always facing the same side. And that is, I don't know it, but I'm staying with it. I've thought a couple of times about it. I say it is because the moon is on that one side heavier. It would make sense. It's not just the Earth pulling the moon in, but also the moon pulling the Earth, and the moon is also a mass, a sixth of the Earth, and is pulling the Earth to it. And now these two parts want to be as close as possible. And the two parts which are the heaviest have the most power to be as close as possible. So it's logically that the most heaviest side of the moon is pointing towards the Earth. And also magnets. I think I've seen that magnets turn around to the side where they have the most pulling force together. So the moon has the most pulling force together where the moon has the most mass. That means the side of the moon facing the Earth logically means that that is the part of the moon which has the most gravity, the most mass and the most gravity. And another thing, maybe it's a bit unrelated, but I think that explanation is pretty good. But I came across that people were doing hydrogen 4-1 in chemistry, and they were shooting a muon particle inside a helium atom, which helium has 2 electrons, and they were shooting a muon particle, another type of particle, in to replace 1 electron with it. And the muon is much heavier than an electron. So now we had a helium atom with a heavy muon atom and a lighter electron. And now we clearly said that the muon, because it is heavier, is closer to the center of an atom. So I said, here's the atom, and the muon is then close to the center of the atom, the electron is further out, and that is because the muon is heavier. So we're saying that because the muon is heavier, it is closer to the center. So it makes sense that the closest part is closer. That means the explanation is that the moon doesn't spin, it's just staying locked with the most heaviest side to the Earth. That's the reason. But I don't know, that's just logically puzzled together. What's now on the far side of the moon? Scientists wanted to know about the far side of the moon, so they sent a space probe Luna 3 to take pictures of it in 1953. The far side doesn't look like our view. There are fewer plains, and the mountain regions are about 5 kilometers higher. Okay. There are not so much plains as there are on the side of the moon pointing towards the Earth. There are less plains, and the mountain ranges are higher, 5 kilometers higher. And there are also more craters because, and that's the logical conclusion, it stands with that side out to the space, and from there the meteor is coming. There comes another meteor from the Earth. The Earth is always carrying a shield. There comes another meteor from that direction. It comes always to Earth. And from the outside there are more craters. So less plains, fewer plains, but the mountain ranges are higher, 5 kilometers higher can they be, and there are also more craters because it stands with that side out to the space. There are from time to time asteroids coming in. Luna 3 was sent into space by the former Soviet Union. Okay, I wanted to know if you had just concluded it wrong. Luna 3, Soviet Union. A space probe, a spaceship sent out by the Soviet Union in 1959. And many of the regions on the far side of the moon are named after Soviet people and places. Okay, how are we going to say it? We're going to first say, I don't know what direction. Maybe we're just going to start and look how it happens. Let's see the second take for what's better. And many places are named after Soviet places, and some things are known about the moon. I think we can conclude it. Because 1959, the Soviet Union sent out Luna 3, a space probe ship, and it took pictures. Did we say it? To take pictures. We say it did. To take pictures, and so many things on the far side of the moon are named after Soviet people and places. I have a second camera. We have a bit time to try to make a presentation on the video. I don't really know how it's structured. with a 3-4 subjects together. The far side of the moon. On the far side of the moon is basically the same as on the side pointing to the Earth, but there are fewer plains and the mountain ranges are up to 5 kilometers higher. And there are also more craters because that is the place where all the asteroids can come in. Where the Earth is where cannot come in the asteroids. So on that side, on the far side of the moon, are more craters. And people wanted to know what is there. So in 1959, the Soviet Union sent out a space probe to take pictures. And that's the reason why many places were called after Soviet people and Soviet places. How the moon stands always like that in one direction because it's just locked. It goes in 1 month around the Earth, but it turns around its own axis once a month. So its face is always with the same side towards the Earth. And that is because that side is heavier of the moon than the other one. So it stays always like that. And most of that is according to Out of This World by Isabel Thomas. I actually know the most daring claims. I'm going to stop the second camera. And that was the Selenology part, when we did what is on the far side of the moon. That means if you were here for Selenology, you can go directly to the next part of Selenology. We will do now the short impingement journey. If you stay and participate in the short impingement journey, then it's very always good. Go to step stand, and we're doing forward shoulder circles. And backwards. And now, long arms, strong fists, and we're going as far back as we can with the shoulders. High up, and in front, and again down, and back, and up, and front, and down, and now backwards. Up, back, down, and front, up, back, down. And now, the accelerating motorcycle is legs wide apart, into the knees, hinge forward to the straight back, let the arms hang, pinch the scapulars together with it. Make fists, lift the arms up and step, pinch the scapulars together. The arms down, the shoulders, and the second round, pinch the scapulars together. Make fists, lift the arms up and step, pinch the scapulars together. Arms down, shoulders down. And now the she jumper. Into the knees. Inch forward with a round back, let the arms hang, make fists, turn the arms to the inside. Lift the arms side up and bring them together. Straighten up, bring the shoulders down, together. Up with the arms together, shoulders down, together. And the second round, into the knees, hinge forward with a round back, let the arms hang, make fists, turn the arms to the inside. Arms side up and together. Straighten up, bring the shoulders down, and together. Now the arms up. If this exercise or any other one causes pain, then don't do it. And just more or less to relax. Down to the side, in front. And now, the world lift backward in stable stance. Long arms, strong fists, shoulders down and together, and turn the arms to the inside. Arms to the outside, shoulders down and together. Arms to the inside, shoulders down and together. Arms to the outside, shoulders down and together. And release. And the next exercise. The arms up to the side, fists in front, bring the arms in front and the shoulders down and together. Arms back, shoulders up, arms in front. Change again. Arms in front, shoulders down, back. And then arms back, shoulders up, release. And a shrug, arms up, shoulders up, and go down. And then our time, arms up, shoulders up, and roll down. And the last time, arms up, shoulders up, and go down. Now the pretzel come, arms together, a bit down on the big side. And to the next exercise. With some diagram. You can use a soccer, tennis ball, whatever. Have it with a long arm at the outside. If you bring the hand into flexion, it is easier to keep the arm straight. Which is intended. As shown next time. And on the other side. And now we're stretching. One arm in front. The shoulder is back. Down. Pull the arm in. Have flat fingers. Try to relax the arm. Go it back with the shoulder. Then the palm a bit up to the sky. Arm shoulder in front. Arm in front. Shoulder back and down. Pull the arm in. Have flat fingers. Try to relax the arm. Go it back with the shoulder. Then the palm up to the sky. This was a short and pinch training. I thank you very much and until the next time.